I've made a lot of videos about robotics, and I just love robotics. Robotics is really just a fun way to program machines to interact with the natural world. And there are so many hardware platforms out there to do robotics. There's the Arduino and the Raspberry Pi. You can even program your phone to be the brain of your robot. So it's really a fun world to get into. Well, one of my favorite new hardware platforms out there is called the Circuit Playground Express. I usually call it CPX for short. And this is such a cool platform. It's very small. It's got 10 LEDs, RGB LEDs around it, and a bunch of other sensors all packed into a really nice, inexpensive platform. There's these cool contacts around the side that you can actually use touch interface. You can grab it with alligator clips. You can use it to sew on your clothes. It can be powered with a small battery, and it's super easy to program. So that's what we're going to talk about today, the new Circuit Playground Express, or CPX. Today we're also going to talk about one of my favorite new integrated development environments, or IDEs. And we're also going to be using Python, which is one of my favorite programming languages. So I'm pretty excited. We're going to program this guy using CircuitPython, which is a flavor of Python specifically made for programming hardware. So let's get started. Just to get us, actually, before we even get started, I need to install CircuitPython on here. If you buy one of these off the internet, there's a chance that CircuitPython won't be the default, won't be installed by default. So let's just do that really quick. Here's how you do it. You go to circuitpython.org, go to downloads, and then look for your particular hardware. So there's lots of great hardware you can use with CircuitPython. Here's ours up in the top left, the Circuit Playground Express. CircuitPython right now is up to 4.1.0. I'm just going to download the UF2 file. When I download that UF2 file, I'm going to put it on my desktop. When I download that UF2 file, there it is on my desktop. I can just drag it over to my device. So right now I've got my Circuit Playground Express plugged in, and it shows up, right now I'm using a Windows machine, and it shows up as cplay boot. It's my D drive. I literally just drag the UF2 file onto that drive, and look, it renames it as CircuitPy. Now I know I have CircuitPython installed. Pretty awesome. So I'm ready to go. So here's my CPX with CircuitPython installed. Let's get started programming. Today, we're just going to do something simple. There's a tiny red LED built into this CPX. I'm just going to program that today, and that'll be probably enough for this video. I'm going to open up Mu, my IDE, and check out this beautiful, clean interface of the Mu IDE. I love it. So let's get started. I'm going to be, like I said, I'm going to be using Python, so I'm going to make a new file. I'm going to start coding Python. Now, real quick about how Python, one of the things that makes Python such a great programming language, it's very modular, it's very extensible, meaning out of the box, Python can't do a ton, but there are so many great packages and modules that I can add into Python that enable it to do cool stuff. Let's do a quick example before we get coding on our CPX. So Python out of the box can do some things like print. So if I say print hi, and I'm going to save this. Oh, by the way, really quick, I'm going to save this as code.py on my CPX. Why did I do that? One of the things that's just so awesome about programming the CPX and other CircuitPython devices is that the way you run code is you just save it on the device. So there's no compiling. Python isn't a compiled programming language. You don't have to do a whole lot to get it to compile and upload. You literally just, because this mounts as a drive, you save to it and it'll run. CircuitPython by default will run anything named code.py or main.py. So I just named this code.py and I said print hi. Now where is it printing? Real quick, this, as we know, is a USB cable. USB is short for Universal Serial Bus. This is a serial communication, meaning one at a time, that goes back and forth across the cable. So when I say when I hit save, I was saving using the serial connection across the USB cable to the CPX. When I say print hi, print is going to go back along the serial connection to my computer. Where do I see that? Well, if you look in the Mu IDE, you can see there's a serial button. If I click the serial button, I can see anything being sent from the CPX across. So right now, if I hit save, I should see hi. Great, there it is. my program ran and it sent serial communication back across the cable. So Python out of the box can do things like print. It can do things, oops, let's see. It can do things like print. It can do math. I can say 5 plus 4, and I can say print that, and it's going to print 9. Great. So Python knows how to print. It knows how to do math. Let's print the square root of 45. Let's do 25 so I get a nice round number. And let's not have a syntax error. Okay. There I go. I'm going to print the square root of 25. Error. Square root is not defined. So Python can do a lot out of the box, but it can't do that much. It can't do square root. So what I'm going to do is I'm going to, from the math module or package, I'm going to import square root. So I'm going to import something very specific. So I'm going to use the from blank import blank syntax to from some package or module of classes and objects and methods, all kinds of stuff. I can import something specific like square root. Now notice down below I said print square root of 25 and it printed 5.0. Because I was able to import from math the square root function, I can do that. So that's kind of what we're going to do today. Let's go ahead and import what we're going to do to make our LED blink. I'm going to say from circuit Adafruit is where it is. Adafruit circuit playground. Spell right. OUGRUND express. Import CPX. So the guys at Adafruit made a whole library of functions and properties and put them all in something called CPX. So now that I've done that, I can say CPX.redLED. Red LED is built into what they wrote equals true. And so in the Python programming language, I capitalize true or false. And in this case, true just means that the light is on. Now, I just saved that, and it was impossible for you to see, but the red LED blinked for like a millisecond because this program ran to completion, and now the LED is back off again. So I'm going to use a trick that is very common in Python programming. I'm going to cause my program to enter into an infinite loop. And the way I'm going to do that is use a while statement, and I'm going to use a while loop. And the way a while loop works is it evaluates everything after the word while, and while that is true, it does everything under the while loop. So I could say while today is Tuesday, colon, and everything under that colon that is indented would run if today was Tuesday. If that actually would work, I could say while counter less than 10 or something like that. So the while statement will evaluate everything after the while keyword, and it'll do everything in a loop as long as it's true. Well, if I want something to happen forever, I can just say while true, because while true is always true. Makes sense? So now if I say while true, CPX.redLED equals true, hopefully you can see this, that the tiny red LED on there is on. So there's my first CircuitPython Express program written on my CPX. Let's do something fun. Let's make this thing blink. So I'm going to define, let's import something. From time, import sleep. So if I want this thing to pause or sleep sometime in the program, I need to import that. I can't do that out of the box. And I'm also going to make a delay variable, 0.5. Let's do that. So in a second, I'm going to use the sleep function that I just imported. And the sleep function uses a delay in seconds. So I'm going to delay for half a second. So I'm going to have my CPX, the red LED, turn on. I'm going to sleep. The sleep function takes a number. I could just say 0.5, but I'm going to use a variable. So I'm going to say delay. So now it's going to sleep for whatever I set as my delay, CPX. And I'm going to have it, let's have it turn off, false, and sleep. Now if I hit save, it should blink once every half a second. Hopefully you can see that. So every half second, that red LED is blinking on and off, every half of a second. I'm almost done with this video. I think that's pretty sweet. I've got a variable. One of the reasons I like using a variable is if I want to change the rate, I only have to change it once. I don't have to go down in my code and change it multiple times. Just as one more example, let's maybe import, let's see, from random, import random. So there's a random module, and there's also within that a function called random. And I can say, let's do this. How about once per loop? I'm going to say delay equals random. And that might actually, oh, then I want to print it. Let's try that. So once per loop, my Python is running the random function, which I imported. It's setting it equal to a variable called delay, and it's printing that delay, and you can see it down below. And then the red LED is on for that amount of time and off for that amount of time. So if you watch the red LED, it's kind of going at a random rate. It's on for sometimes almost a whole second, and then on for, let's wait for something really quick, like 0.3 seconds. That one was pretty fast. By the way, the random function by default just spits out a number between 0 and 1. That's pretty handy for this program. I think in later videos, we're going to use these fun RGB LEDs, but I think that's a pretty good introduction to a lot of new stuff. New hardware, the CPX, new IDE called Mu, and a new language called CircuitPython. Really fun to program. You just have to import everything you need. Fortunately, the guys at Adafruit made a really nice module called CPX. And notice I've made an infinite loop called a while loop. And just notice that the way the Python programming language works is there's no curly brackets or other forms to encapsulate code. It's just everything that's indented. I think that's it. Enjoy, and check out my next video for more on these little guys called NeoPixels. Thanks.